Okay, good morning students. In this class we discuss about how the refractive index of a prism can be determined. That means we are obtaining an expression for refractive index of material of prism. From that we can explain how the light undergoes dispersion. That means when white light is allowed to pass through the prism, it will split into constituent colors. That process is called dispersion of light. Okay, the splitting of white light into different colors is called dispersion of light. How that dispersion of light takes place when passed through prism. For the purpose, first, this is the prism. The prism having five plane surfaces which are inclined in the form of a triangle. Generally, this is made of either crown glass or flint glass. Among these three surfaces, two surfaces are transparent surfaces, another one is the rough surface. These two surfaces are called refracting surfaces because the light incidents on one surface, after refraction pass through the prism, again emerge from the other surface. And the edge where the two refracting surfaces meet is called refracting edge, and the angle at the refracting edge is called angle of prism. Generally, the prisms are prepared in the form of an equilateral triangle, so automatically the angle of prism is 60 degrees. Now we are going to obtain an expression for refractive index of this prism. For the purpose, let ABC is the prism. ABC is the prism. AB and AC are the refracting surfaces, and BC is the rough surface. Now the light incidents on one surface and emerge from the other surface. Now a light ray PQ is incident on the refracting surface AB, and this is the normal. After refraction, it travel along the path QR. Again, we draw another normal here. Again, the light undergoes refraction and finally transmitted along the path RS. The light ray PQ incidents on the surface AB. After refraction, it travel along the path QR. Again after second refraction, it transmit along the path RS. Here I1 is the angle of incidence and R1 is the angle of refraction. Here I2 is the angle of emergence and R2 is angle of refraction. That means if we reverse the direction of light, it will transmit it along this path. Now if the prism is not there, the light traveled in straight line, but due to the prism, the light is transmitted like this. Here the light undergoes bending when passed through the prism. To find out at what angle the light undergoes bending, now if we extend the incident ray in forward direction and emergent ray in backward direction, they intersect at one point. This is PQRST, intersect at one point. This gives the angle of bending, the angle of deviation produced by the prism. Angle of bending or angle of deviation produced by the prism. By symmetry, here at this point the angles will become I1 minus R1, and here the angle become I2 minus R2. Again from triangle QRT, the sum of angles in a triangle is 180 degrees. So from the triangle QRT, R1 plus R2 plus T, R1 plus R2 plus T equal to 180 degrees. Again from this, T equal to 180 minus of R1 plus R2. Let it be equation 1. Again from the quadrilateral AQTR, the total angle in the quadrilateral is 360 degrees. So angle at A is A, angle of prism, plus angle at Q, this is the normal, so its angle is 90 degrees, plus again T at angle T cap, plus here this is the normal, so here at R the angle is 90 degrees, equal to 360 degrees. 360 degrees. From this, A plus 90 plus 90, 180, plus from equation 1, let it be equation 1, from equation 1 T is 180 minus of R1 plus R2 equal to 360 degrees. Okay, from this we have A equal to 360, 180 plus 180, 360. If it moves that side, it will become minus 360. Again, this minus of R1 plus R2 will become plus R1 plus R2. Now, this post gets cancelled. A equal to R1 plus R2. A is equal to R1 plus R2. Equation 2. A equal to R1 plus R2. This is equation 2. Again, from the triangle QUR, if we draw the triangle QUR separately, this is here at Q angle is I1 minus R1, at R angle is I2 minus R2, and at U this is D. The total angle is 180 degrees. Then 180 minus D gives the angle at U. So from this triangle QUR, angle at Q I1 minus R1 plus angle at R I2 minus R2 plus angle at U 180 minus D equal to 180 degrees. Equal to 180 degrees. Now from this I1 plus I2 minus R1 minus R2. If we make minus as common, we get R1 plus R2 equal to, this will become 180 minus 180 plus D again I1 plus I2. I1 plus I2 minus, from equation 2, R1 plus R2 equal to A. Then A equal to plus 180 minus 180 gets cancelled, we get D. From this I1 plus I2 equal to minus A will become plus A. So A plus D. This is the equation 3. Equation 2 is A equal to R1 plus R2 and equation 3 is I1 plus I2 equal to A plus D. Here simply we are taking triangle QRT at first, again from the quadrilateral AQTR, again from the triangle QUR we are applying that one. Here the experiment is done in such a way that first the light is allowed to incident at some angle on the prism and find out the angle of deviations. Suppose I1 is the angle of incidence, then D1 is the angle of deviation produced in it. Later the light is allowed to incident at another angle and note down the corresponding angle of deviation produced by the prism. And first the light is allowed to incident at some angle, say 30 degrees. Find the angle of deviation. Later 35 degree, find the angle of deviation. 40, find the angle of deviation. Like this the angle of deviations are calculated, like determined for different angles of incidence. And if we draw a graph between angle of incidence and angle of deviations, we get a curve like this. From this it is observed that with the increase of angle of incidence, the angle of deviation decreases, becomes minimum. After that it gradually increases. At first, with the increase of angle of incidence, the angle of deviation decreases, becomes minimum, then the angle of deviation increases. Now, if you draw a horizontal line for a particular angle of deviation, this horizontal line intersects the curve at 2 points. If you draw the normals from that point onto the x-axis, we are getting I1, I2, 2 angles of incidence. That means for this angle of deviation delta 1, there are 2 angles of incidence. And whenever the light incidents at this angle I1 or I2, the angle of deviation is D1. Again, if you draw another horizontal line, this will also intersect the curve at 2 points, which means that this angle of deviation D2 having 2 angles of incidence, I1 and I2. But whenever at angle of minimum deviation, and when the minimum deviation is minimum, when the angle of deviation is minimum, here at that point I1 and I2 will coincide. I1 and I2 will coincide. That means at angle of minimum deviation, at minimum deviation, I1 equal to I2. I1 equal to I2. Automatically R1 equal to R2. Automatically R1 becomes equal to R2 according to Snell's law. According to Snell's law, sin I by sin R is constant. If I1, I2 are same, to keep sin I by sin R constant, R1 and R2 must be same. Therefore, and that means at angle of minimum deviation, I1 is equal to I2, that equal to I say, and R1 is equal to R2, that equal to R say. Now substitute these values in equation 2 and 3. From equation 2, the equation 2 is R1 plus R2 equal to A. R1 plus R2 equal to A. From this, R plus R equal to A, or 2R equal to A. From this, R equal to A by 2. R equal to A by 2, where A is angle of prism. Again, from equation 3, equation 3 is I1 plus I2 equal to A plus D. I1 plus I2 equal to A plus D, but at angle of minimum deviation, D, angle of deviation will become angle of minimum deviation, and I1 becomes equal to I2, that equal to I say. If you substitute these values in this equation, I plus I equal to A plus delta. From this, 2I equal to A plus delta. From this, I equal to A plus delta by 2. I plus delta, A plus delta by 2, where A is angle of prism and delta is angle of minimum deviation. Here, the light when undergoes refraction through the prism. Whenever the light undergoes refraction, it follows Snell's law. According to Snell's law, N2 by N1 equal to sin I by sin R. Sin I by sin R. Here N1 is the refractive index of first medium and N2 is the refractive index of second medium. Here the prism is placed in air. So the air becomes first medium, prism becomes second medium, because the light passing through the air medium and incidents on the prism, after refraction it passes through the prism. So the first medium is air and the second medium is prism. We know that the refractive index of air is 1 and the refractive index of prism is equal to N say. Then if you substitute these values in this equation, we get N by 1 equal to sin I. What is I? A plus delta by 2. A plus delta by 2 by sin R. What is R? A by 2. A by 2. Or we can write A equal to sin, N equal to sin of A plus delta by 2 by sin of A by 2. By using this expression, we can determine the refractive index of material of the prism. Refractive index of material of the prism. Here, N is the refractive index of material of prism, A is the angle of prism, delta is the angle of minimum deviation produced by the prism. By substituting A and delta values in this equation, we can determine the refractive index of material of prism. in case of thin prisms. Thin prisms means thin prisms means if the angle of prism is less than 10 degree, this angle becomes small. From trigonometry, for smaller values of theta, sin theta is nearly equal to theta. So for thin prisms they will become n equal to a plus delta by 2 by a by 2, because sin theta is nearly equal to theta. From this, 2 gets cancelled with each other and n equal to a plus delta by a plus delta by a. From this, na equal to a plus delta. From this, na minus a equal to delta, or if we make a as common, we get n minus 1 equal to delta, or delta equal to a into n minus 1. From this expression, a is the angle of prism, remains constant. From this equation, delta is proportional to n minus 1. Delta is proportional to n minus 1. Let it be equation 4. It's a very important one. Here, from this expression, if the refractive index is less, the angle of deviation is less. If the refractive index is more, the angle of deviation is more, because the angle of deviation is directly proportional to the refractive index. Also, we know that the refractive index of a medium is defined as the ratio of speed of light in vacuum to the speed of light in the medium. The ratio of speed of light in vacuum to the speed of light in the medium is called the refractive index of that medium. Here c is constant, then we have n is proportional to 1 by v. N is proportional to 1 by v. Let it be equation 5. From this equation, if the speed of light is less, refractive index is more. If the speed of light is more, the refractive index is less. Also we have the speed of light is given by v equal to nu lambda. The speed of light is given by v equal to nu lambda, where nu is the frequency of light and lambda is the wavelength of light. Here, whenever the light ray move from one medium to another medium, the speed of the light changes. So whenever the speed of the light changes, either frequency or wavelength must change. But when the light ray move from one medium to another medium, the frequency is not changed. Only the wavelength is changed. Wavelength is changed. Wavelength, amplitude, intensities are changes. Then from this, v is proportional to lambda. V is proportional to lambda. From this expression, if wavelength is more, the speed of light is more. If the wavelength is less, the speed of light is less. Now from these three expressions, we can explain the dispersion of light. First, the equations are delta is proportional to n minus 1. The next one is refractive index is inversely proportional to speed of light. The next one is speed of light is directly proportional to wavelength. From this expression, if the wavelength of light is less, speed of light is less. If the speed of light is less, refractive index is more. If the refractive index is more, the angle of deviation is more. Ala kakunda, if the wavelength of light is more, the speed of light is more. If the speed of light is more, the refractive index is less. If the refractive index is less, the angle of deviation is less. And here, when white light is allowed to pass through the prism, white light. We know that white light is a combination of 7 colors: violet, indigo, blue, green, yellow, orange, red. Among this one, the violet having less wavelength and red having more wavelength. That means as we move from violet to red, the wavelength of light increases. Here, first, the violet having less wavelength, automatically the speed of light is less. If the speed of light is less, refractive index is more. If the refractive index is more, the angle of deviation is more. The angle of deviation is more. That's why the violet light undergoes more deviation, more bending. Whereas if you take the red light, red having more wavelength, automatically the speed is more. If the speed is more, refractive index is less. If the refractive index is less, the angle of deviation is less. That's why the red color light undergoes less bending, and emerge like this. And in between violet and red color, the remaining colors are reaches. Like this, due to the variation of refractive index with wavelength, we are getting the dispersion of light.